Hello everyone, my name is Merrick McKenzie and my project is over mobile application data exposure and vulnerabilities. I'm going to be breaking down how phone apps can accidentally leak personal information, why it happens, and what we can do to stop it. Mobile apps handle a lot of our personal information, things like location, messages, and login details, and different data we give the apps without even realizing it. When security behind the app is weak, the information can end up exposed while it's being stored or sent across the network. A lot of these come from simple mistakes in how the app is built, like poor coding or missing security checks. When that happens, users can lose their privacy and have their information used in ways they didn't expect. That's why mobile security matters, especially now that apps keep growing and collecting more data. In this presentation, I'm going to be breaking down what data exposure really means in mobile apps and how these leaks happen in the first place. I'll go over situations where apps accidentally reveal personal information and show real examples of what leaks look like. I'll also break down the parts of an app where things can go wrong and why they are important. And then I'll go over why the ways these vulnerabilities can be prevented so apps can handle user data safely. Data exposure is when an app lets private information be seen by someone who shouldn't have access to it. This can happen in two main areas: while the app is being stored on the device, or while the data is being stored on the device, and while the data is being sent across the network. With weak data storage, that becomes vulnerable to data extraction attacks. If things like login details or tokens are stored poorly, that can lead to credential theft. And even simple app logs, if exposed, can be used for information gathering attacks because they reveal how the app truly works. For weak data transmission over the network, insecure traffic opens doors for man-in-the-middle attacks. If the data isn't encrypted, it can be captured through packet sniffing attacks. And as session tokens get exposed, a hacker can perform session hijacking and completely take over. These kinds of issues usually come from weak security choices, or small mistakes in the app's design. And when data exposure happens, it can reveal things like user details, app behavior, or even stored files. How apps use data. Apps use data in a few different ways. They collect information and make the experience feel more personal for the user. A lot of that information is sent to the server, and to do that, an app has to package the data, send it through an API or a network request, and the backend will either process it or store it. Apps also keep data on the device. This is done so the app loads faster, can work offline, and is able to save things like user preferences or recent activity. Then you have background processes that run quietly, handling the things like syncing, notifications, and overall app updates. Every part of this flow, collecting, storing, sending, and processing, create a place where something can go wrong in security if it isn't handled right. If security isn't handled right. Data at risk. Mobile apps deal with a wide range of sensitive data depending on what the app does. This includes basic personal details, login info, location data, and anything the user interacts with through the app. When an app isn't secured properly, personal details can end up being exposed. This includes things like someone's name, email, number, account info, or even their location or activity inside the app. Apps usually store some data on the device to make things run faster, like I said, and work a lot offline, like I said. If this local data isn't protected, the one that's stored on the device, it becomes very easy or an easy target for attackers, like saved files, cached items, and app history, and everything stored without encryption can be misused. Background processes also carry sensitive information, and attackers can target that too. Things like notification sync data and session tokens used to keep someone logged in can all be misused if they are not protected. Why leaks happen? Leaks are often caused by weak or missing security in the app. Apps could skip basic protections and give attackers an easy opening to access private information. Weak security choices during development can also lead to data leaks. Using no encryption or weak encryption makes sensitive information easy to steal. Storing data in unsafe locations or sending it over insecure connections increases the risk even more. Leaks can also happen because of mistakes in how the app was built, like sample coding errors or oversights can accidentally open more doors for the attackers. Developers sometimes leave keys or secret ideas in the app, and incorrect permission settings can create vulnerabilities. Also, third-party tools can create risk for an app, and apps rely on outside libraries and SDKs, and if those tools aren't secure, they weaken the entire app. And for old and unpatched components, they can bring vulnerabilities, and attackers can take advantage of that. How a data attack happens. Attackers often start by going after data that an app sends across the network. They first connect to the same Wi-Fi as the victim, use a sniffing tool to capture traffic, and then read any data that isn't protected or encrypted. They can also go after data stored on the device. If they get access to the app's files or local storage, they can open unprotected or plain text files. From there, they can pull sensitive data directly off the device. These attacks work because the app didn't protect the data well. Without strong enough encryption or safe storage practices, it becomes easy for the attackers to get the information. Some apps still send their data without even using encryption. Like when they use HTTP instead of HTTPS. When that happens, the data travels in plain text, and everyone on the same network can see it. In this kind of attack, the attacker just needs to join the same Wi-Fi network as the victim. Then they would use a packet sniffing tool again to capture the app's traffic. If the data isn't protected, the attacker can read things like login info or tokens. So while the data is moving, personal details, account data, and personal information can all be exposed. That's how a network leak happens. For a storage leak, apps can leak data when they store it without encryption. Some apps will store the data in plain text or leave information unencrypted, and this can include things like logs, cache files, or saved data that the app didn't protect. Attackers access the device or app storage. If someone gets access to the device or the app folders, they can open the files directly, and anything that isn't protected can be viewed or pulled out. Sensitive information gets exposed on the device. Because the user data was saved unprotected, things like user details, app activity, and login tokens can be exposed. For my real case, I have the Strava app where they had a location leak for a military base. This is a real example of a data leak from the app Strava. Soldiers would use the app to track their exercise daily. Strava had a heat map that showed where people ran or walked. The problem was that it also showed the GPS routes from soldiers on military bases, which is this photo I have. Um, so the paths of the soldiers were visible to everyone online. The app made these routes public by default. Most users didn't even know their location was being posted. This leak happened because Strava didn't protect or limit the GPS data. The privacy settings were weak, so everyone could view the activity on the map on the app. This case shows that regular phone apps can have a mistake and expose sensitive information. For defensive strategies, use strong encryption for all data. Apps should encrypt any data that is stored or sent. They should always use HTTPS or TLS for all network traffic, so nothing travels in plain text. Protect data stored on the device. Developers should avoid saving sensitive information in plain text on the device. Both iOS and Android have secure storage tools built in, and apps should just use these instead of making their own weak tools. Secure the app's code APIs. Securing the app's code is also very important. Developers shouldn't hardcode keys or secrets in the app, and the API needs proper check, so attackers can't pull data they shouldn't have access to. And improve all permissions in settings. Apps should only ask for the permissions they actually need. This helps limit when an attacker can reach your information. Next, best practices. Keep apps updated. Keeping apps updated is very important. Each update will help fix security problems, and remove weak points. Be careful with app permissions. Apps should only get to the permissions they actually need, and if the permission doesn't make any sense or seems unneeded, deny it. Use safer networks. Avoid using any public Wi-Fi when doing sensitive information online. Developers should check for leaks, of course. They should test their apps by checking network traffic, reviewing stored files, and making sure sensitive data isn't left unprotected. For the future of mobile security, I believe stronger built-in protections from iOS and Android will be coming. This includes stronger encryptions and stricter app permissions that control how much the app can access. Smarter threat detection. Phones already can automatically spot suspicious activity and block risky apps or connections, and they're getting better and better at detecting unusual app behavior. More secure app design. Developers are using safer tools now, and there are better rules for storing and sending. And as time goes, better tools will come out. Better user control. Users will also have clear privacy settings, they will be able to understand it better. The older people will be able to look at it and understand it more. And there will be more ways to limit that, what the app can access and all. Yeah. To close everything out, mobile apps can expose data if security is weak. If the protection is weak, the information becomes much more easier to access. Most leaks come from two places: the device storage or the network, the transmission. And if either of those are unprotected or unencrypted, data can be pulled or stolen. Attackers would use these weak spots. They can read unprotected files or capture traffic that isn't secure. So you want to have your stuff secure. the real case we looked at shows how serious leaks can be, and using strong security and good app design can prevent a lot of these issues. And users also play an important role by keeping devices updated, watching permissions, and avoiding unsafe networks. And here are my sources. Thank you.